The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. I'd like to welcome you back to another KevCAM night class tonight. Tonight, I have Greg to help us out and make sure I'm covering everything. Greg, you with us?
Good evening, everybody.
And I do see a lot of our regular names in here, so we won't go through the boring introduction. And we will get the ball rolling right away with the HSS projection offset tonight. Now, jump right into it here. Now, what does the user-defined offset do for me? Basically, the strategy projects a curve selected in the projection curves, and basically, so trying to give this the easiest way. Think of it as a pencil milling pass, but being able to add multiple passes in there and being able to tell it how many passes that you would like. So instead of me trying to tell you guys what it does, let's just show you what it can do for you. So first thing what I'm going to do is we're going to focus on machining out this radius right here. So for this particular one, I'm just going to do a parallel to curve real quick. So we're going to do a little bit of repeat here. And my drive surface is going to be that, as well as my edge curve be that guy. And we'll go ahead and grab a tool. Using our 1/4-inch ball end mill here. And
now I know a lot of people in the class are regulars and probably have caught the other classes, but for the people watching on YouTube, there are other classes, other videos that you can check out. If Parallel the Curves is looking pretty new to you, there is a video that goes over this functionality in depth.
Yeah, great point. So Parallel to Curve is just kind of go through. We've done so much HSS. Parallel to Curve is right here for you guys. So definitely come check that out. All right, so we're doing machining down this wall right here. I'm going to set my step over to 10 thou, as well as get rid of my links, and I'm going to switch my sorting to spiral. Now, let's go ahead and see what we're looking at. So what I did to start off, did a 3D machining, got everything roughed out in there. Now we'll go ahead and play this through, starting at the bottom, working our way up to the top of that radius. But what you can see in here is we have square corners. So if I do an execute, I can still see that I have material left over right here, as well as all 4 corners. You can see I still have, let me get zoomed in here, I still have material right there. Now, there's more than one way to skin a cat. So I can come in here and I could do a surface extension for my start, and that would clear it up. But I will get some air cutting because I will be recutting this floor that's already finished for us. Or what we can do is use our HSS projection and get that trimmed out of there. So we'll start off with HSS, and we are going to go down to projection, offset. Now my geometry, I'm going to grab just the flat floor here, because that's basically this triangle right here is what was left over. Okay. Now my projection curve, grab this one, and we'll do a constant Z to go all the way around. So that's the curvature that I would like it to follow. Now, real nice thing in here is what I'm going to do is I'm telling it to do a left or inside offset. So I have the choice in here of doing a left/inside, a right outside, or I can actually do both. So what that saying is, let's leave it just on left right now, is going to go left of my projection curve that I chose and do a pass. Now I can tell it right here that number of cuts to the left, I can just tell it 1. And basically, let's go ahead and grab a tool. Our ball end mill. And simple as coming in here, and our 1 pass is doing it right on the curve that I told it. And then our next pass, which is our additional one that we told it, is over right here. Now, we can set up our toolpath parameters. So we'll do our same step over. So our 10 thou is what we did before. But now if I do a simulation, play it through, we can still see that I need to do more passes in there, okay? So now I can come back to my geometry and let's just do 10 cuts. So if I do save and calculate, we'll see 11 tool pass on here. Okay.
Now, Kevin, for this, would you recommend turning on the updated stock?
Oh, just hold on, we're getting there. Oh, the updated, I'm sorry, the updated stock. I was thinking one other thing there. Sorry to jump a case there, Greg. All right, so what Greg is saying is we can turn on our updated stock at this point, drag it down, and that's a great point. So right here is my updated stock from the previous operation. So from this operation right here is showing me right there. So right now, and we're doing, let's just make sure we're 100% straight down view here. I can tell that, all right, well, if I did 10 passes, I would have 2 passes that wouldn't even touch where I need to clean up here. Because here's our corner right here, this little triangle that we need to clean up. But what we can also do in that situation, let's just play it through and see here. All right, so now let's go ahead and play that through. And I can see that I was able to clear off all the material there. We can do our stock target comparison, and as long as we're orange, yellow, or light green, we're good. But to go back to what Greg was talking about is I have 2 passes right here that are cutting air or not cutting any material, as well as all these additional cuts down here that are already up to size that I don't want it to go across. So I think we've talked about this in the past, but what we can do at this point is go to roughing and more and turn on our stock definition at this point. Choose the avoid air cuts. So what this does is it looks at this updated stock right here, and any tool path that is not touching the stock or the updated stock, it will trim off those additional tool paths. So let's go ahead and save and calculate. All right, so now we can see that we're lifting up and we're just coming in there and nipping out those corners. And then it's coming up to the clearance and moving over to the other area. Personally, we don't need to go up to the clearance. So what I'm going to do in here is go to my link and my links. And instead of going to clearance area, we'll just do safety distance. And there we go. So now we can see in there that the software is doing all the work for you and trimming out any additional path using a high feed movement and just coming in here and nailing out these corners. So now if we look at this through our simulation here. So now you can see we're just getting those corners. We can do our stock target comparison. We're up to size, as well as we're not dragging that ball end mill across a finished floor area. And the reason why I say that is because when we're doing this floor process right here, we're doing a nice pocket routine, getting a nice pretty finish in there, and we don't want to have any tool drag marks as we're going to the next section. So now we're just working on those little areas right there, keeping it there, and then bouncing over, going up to the safety level for you guys. Now, what I'm going to try to do here is, I haven't tried this before, but if I go, let's do one way, and then I was thinking we could get it so it stays in one area, one region before it goes to the other side, but for some reason I'm not seeing that option. Oh, so there must not be an option. And usually if we're doing parallel to a curve, or you have the option to do, I can't think of the name of it. Let's open it up. Let's see.
Yeah, you're talking about sorting it by regions.
Yeah, yep. So machine by lanes. So what I was looking for is to do by regions, like what Greg was saying, but unfortunately that option isn't there. So it is going to move around going all the way through. But if you want those tooling marks in there, we can remove that stock in our roughing in more here. So if you don't mind those tooling marks going all the way through, then we can turn that off, as well as we could switch it also to our link section and just do a direct.
Now, Kevin, with the after we do the direct, I say we go back to the safety distance and maybe show the lead in, lead out, because especially on stuff like this, it's nice to have a nice horizontal tangent arc that kind of has a little bit of a helix to it. That way you're coming in off the floor, kind of ramping into that cut and then back out.
So what we'll do here is we'll use lead in, lead out. We'll go to our default and vertical tangent arc, I think is the one we're going to want.
Yeah, well, yeah, either or will probably do it.
So kind of
I like a horizontal tangent arc if we got the space for it. And then under the height box down below that, you can specify a distance to kind of make it into a helix. So like if we put that at like 10 thousandths, it'll stay off the floor by 10 thou, ramp into that cut, and then back out. Beautiful.
So now let's turn off our updated stock for a second.
Although, are we actually getting arcs? No.
I don't see an arc in there. We have to do something a little bit bigger here.
I don't know that's necessarily on the height.
Yeah. So I think we just needed more distance in there for a height. But yep, so now, all right, so to kind of compare back and forth here. So right now we're coming in with our ball, coming down, and we're arcing into that material. Now, if I wanted to, what I can do is come in here and I can tell it, all right, as it's arcing into the material, I want to do it at 50% of the feed rate. So now we're in the high feed move right here, coming down, and as soon as we hit right here, we cut our feed rate in half as it gets engaged in the material, and after the arc has stopped, then it will go to a feed rate of 100% that we specified with the tool data. Now, if we go back, and definitely this is much cleaner, much easier on the tool, you get a nicer surface finish. If we go back to our links and tell it, don't use lead in, lead out, we will see that we're coming in here, coming down, and we're doing a straight plunge into the material. Now, the problem with that is, in a perfect world, yeah, works great. But as we know, our machines, as we're coming down on the Z, we're going to get a little nip, or like a witness mark right there. And we obviously don't want that. I mean, it can get buffed out with Scotch-Brite or emery cloth or whatever. But to eliminate that, definitely use your lead in, lead out, and that will eliminate those issues that you would have right there. So now we're doing a nice swoop arc in there. We're slowing our feed rate down. You guys will have a phenomenal finish in there. And as you can see, we have one entry, one exit going all the way through the part. So, any questions from anyone?
Not seeing anything in the questions panel.
Any questions that Greg can stump me on?
No, I think this one is pretty straightforward and surprisingly useful. I've used this one quite a bit in the shop.
Yeah, this one also works good for, you know, if you guys are doing engraving, but think of the projection offset as kind of like a pencil milling pass. You just want to come in there and clean up just a little bit of material in a specific area. And like I said, you can use that stock in the roughing and more, use your stock definition to really fine tune it. I really like using this feature because it almost reminds me of using iMachining, where we don't have to worry about cutting air. It looks at the updated stock as well as the model, and it trims off any additional tool path that does not need to be there for you guys. So definitely a nice feature to use in there as well. So, well, that is everything. Like I said, it's going to be a shorter night class tonight, but that's everything that I could think of for the user-defined offset. Now, next week, both Greg and I will be in San Diego, and then the week after that, I will be in Maryland. So we won't have class for 2 weeks, and then after that, I'll get the schedule put out for you guys, and we are going to get going with
more HSS?
No, we are done with HSS. So crack the champagne bottle and
we made it.
Yeah. No, I should say our students have made it through. So in 3 weeks, we will be having a class, and we are going to be going through mill turn. Everything about mill turn. We have a customer of ours that sent us not so much a complex part, but a part that he would like to see program live without adding any tools in there. So we are going to start this part from start to finish. We are talking live tooling in there, creating the tools in there, as well as, we got a couple people in here. Let's take a vote. Do you guys, let me ask you this. Do you guys want to see the mill turn and advanced mill turn step by step, or do we push that back and start going through the new features inside of SolidCAM 2021? So you guys tell me, do you want to go over SolidCAM 2021 or the advanced mill turn for the next rack of classes? No 2021. Does that say no 2021 or no, you want to do 2021?
I think that's a vote for mill turn.
Oh, is that what it is? The other, not Greg Pate. Okay, mill turn. Okay. We'll go off of what our users want. So in 3 weeks, we'll be starting on that mill turn. I will be showing it to you guys in SolidCAM 2021. but we will be going through that part inside and out. And I know when I programmed this part 6 months ago, I learned quite a bit off of it. So like I said, there's some really intricate features in there that aren't hard, but are a little bit of a head scratcher. So hopefully you guys will get something out of that. But
now, as a teaser, what kind of machine will you be programming it on?
this is going to be on a, well, Greg, you're going to have to help me out here. What is ALS? What do they have for their machine?
Oh, Doosan Puma.
So
I forget the exact model of it.
okay, so it will be done on a Doosan Puma.
But we're talking dual spindle, single turret with Y-axis control?
Yep.
Okay,
so,
cool.
Yep, so we'll show you guys all the ins and outs of doing a complex machine like that and the part, and go from there. But
yeah, it looks like officially it's the Doosan Lynx 2100 LSYB.
Perfect. So hopefully, Greg Malloy, is what kind of mill turn machine do you have? Since he was the one asking for mill turn. He's frantically typing. I can hear him. No kidding. Well, while I wait for his to come in, I'll let the rest of you guys to go. And like I said, no night class for the next 2 weeks, just because of on-site training. And if you guys are interested in on-site, let us know. But so the next 2 weeks we'll be out, and then the week after that we'll get into the advanced mill turn, and then we'll actually have a week off because I got to go do another on-site, and then we'll be back at the mill turn stuff going forward there. So that being said, I want to thank everyone for joining the night class tonight, and definitely want to welcome all of your guys' ideas over. And please let us know if you guys do have ideas that you would like to see in the night class. And if I don't talk to you guys in the meantime, we will talk to you guys in 3 weeks. Thanks, everyone. Have a great rest of your night.
Good night, everybody.